Easy, man. Easy. I'm Hamish, but a lot of people sometimes they call me Now River Soldier. You know what I'm saying? Now River Soldier. Or you can call me Bacteria. Okay? 25 Bacteria or Hamish. Now, we don't want to waste your time. There's a lot of new ones here, okay? So if you're new, just come right here, okay? There's a subscription button, subscribe, so that every time you get notification. Let's get started. So now we have this function. So by looking, we got two types of function. We have this function here, which is logarithmic function. This is logarithmic function. Even by nature of the graph, look. Logarithm most of the time is like this. You know what I'm saying? That's a logarithmic. Oh, sometimes it could be like this. It kind of look like exponential. So that's a logarithm when in that form, okay? That's a logarithmic function, just the nature of a graph. Now, also we have a straight line. So there's a straight line here. We see straight line. Okay, now, what do they want us to do? They say sketch shows me. This sketch shows the graph of the function h. And this is h. See, this logarithmic is h. N, L, y equal to L. So what do they want us to do? Excuse me. We have a coordinate of, there's a coordinate here. Let me just check quick. I think I forgot to write the coordinate. I'll follow just a second. Okay, where the coordinate? Yeah, that's coordinate. It's coordinate A. Okay, so there's a coordinate A here. I forgot. Means so if by looking there's a two intersection here, the graph they intersect each other, and here where they meet up intersect. So we know whenever the coordinate the graph intersect, you take those coordinates and then you substitute in any of the two graphs which intersect because they have a common coordinate. Oh, so what we're going to do here, we know the coordinate of A. What is A? X equal to 4. And then what is Y? Y equal to 7. Both a straight line and logarithm, they share the same common point. Same here. Value of B equal to 12. And this is equal to 9. So I might take this, I can take this coordinate A and substitute in either of the two. So what do they want now? They say find the point A and B. These are graph of either intersect at point A and B. Now what do they want? Use the graph to match point P and Q. But where is P and Q? P and Q, it lies on h of x. Oh, so for that case, I'm going to use this coordinate on, because P is on a logarithmic function. P and Q. So I'm going to take the first coordinate, substitute in this logarithmic, and even the second coordinate, substitute in this logarithm, and then I'll solve normal. Why do I do that? Because these points, they lie on logarithm. You know what I'm saying? But if it was something has to do, find the coordinate of straight line, which is this, I was going to substitute this coordinate on here, and this coordinate on here. Let's go. So it can make a lot of sense, because we can just do like we do history, eh? This is not history class, this is mathematical class. You know what I'm saying? So now let's go. So now we're going to say now, so what start with 4, 7, so start with the 4, 7. This 4, 7, we're going to substitute in logarithmic function. So this is y, this is x. But so what is the y? Y equal to 7, so this is going to be 7. 7, and then equal, log, base 3. Okay, what is the x? X equal to 4. And then minus, pp, and the plus q. Do you know q? No. You know what I'm saying? Now, what I'm going to do, take this one over. You know what I'm saying? Because this stuff is attached to q. So, take this one over, it's going to be 7 minus q equal to log, and they have base 3, and then this is 4 minus b. So, there's something here I want to show you. It says something called exponential rule. Exponential rule, if somebody give you, if somebody give you log, let's say x, let's say this is y or 2y equal to 0. They say find the value of y. So you can apply exponential rule here. How does exponential rule? Exponential rule works. Look, if there's no base here, I mean this is under base 10. So for exponential, you only apply exponential when you have a log on one side and another side must be a number. So how are we going to apply? Now you push this number to this side. So it's going to be equal. This 10 is going to come here, and this is going to go up. It's going to become as a power, and then here write 2y. Log disappear. The log disappear. That's how exponential rule works. Divide by 2, divide by 2. This and this cancel. So y equal to any number plus 0 equal to 1, so 1 over 2. Just one more example. So somebody give me log, or let's say this is it could be y, and here let's say 3 equal to negative let's say 1. So how am I going to solve this exponential? I can apply exponential rule here. Why? Because there's a log one side, and another side is a number. So how I'm going to do that? I'm going to push this number to the whatever other side. So it's going to become 3, and this is going to become as a power. It's going to raise up, and then equal. See this side, log disappear, and then we write what we left with here, which is y. This time we say 1 over 3, if you reciprocate, 1 over 3 power 1 equal to y. You know what I'm saying? So that's how you do exponential rule. So I'm going to do the same game here. I'm going to push this one here because I want to solve this question letter simultaneously. Why? Because I'm going to do the same thing for the second one. So now I'm going to say, okay, so now I'm going to say push this one here is going to become 3. This is going to be 7 minus q equal to, because 3 come here is going to become 3. This is going to become as a power or exponential. So log is going to disappear and the 3 went there, so it's going to be left with 4 minus p. Oh, 4 minus p. Oh, okay. So 4 minus p. Oh, I can make the p subjects. It's not decided, but I can make p subjects. So for that case now, we're going to say our p, if it comes here, is going to become positive. Look, this p come here is going to become positive, and then we're going to take this half to the right. So this p is going to become positive. If you take over here on the right hand side, it's going to be 4. It's going to become minus 3, 7 minus q. Okay, cool. So let me call this first equation. So I'm going to do the same approach for these coordinates. You know why? Because those coordinates also rely on the logarithmic function. So what is y? Y equal to 9. So here I'm going to say 9 equal log 3, 3. Okay, bracket, bracket. So what is the x? X equal to 12. So we say 12. And that's going to be 12. And then minus p, and then we plus q, we plus q. So we're going to do the same game. This 9, q come over. So it's going to be 9 minus q. And here we're going to be left with log under by 3, 12 minus p. Exponential rule, you're going to push this one here. When you push that one there, so what's going to happen? This is going to become 3, 9 minus q equal to, okay, here this is going to fall away and this one went over, so it's going to be 12 minus p. So then we want to make p subjects, you know what I'm saying? So if you make these p subjects, it's going to become p, means this p, go to the left, it's going to become positive, and then this 12 is going to be here on the right hand side. We take this to the right because we want to make p alone, you know, so you'd rather take this to the right, it become positive, and then 12 take over, it's going to be minus 3, 9 minus q. Okay, so this, where is that? Where is the this? First equation and second equation, both equal to p. You know what I'm saying? Equal to this, p equal to this, so I can equate them because this equal to p and this equal to p. So let me take this equal to this. Okay, now we go. So now we're gonna say 4, which is 4 minus 3, 7 minus q equal to 12 minus 3, 9 minus q. Now, so we can get the value of q. How are we going to get there? Take the group of 3 together and group the other number together. You know what I'm saying? So now this is going to go to the right. So here, if this go to the right, it's going to become positive. So it's going to become positive 9 minus q, and then this is minus, which is 3, 7 minus q. And then this side we have 12, and then this 4 is positive. When we go over, it's going to become minus. So 12 minus 4 is going to be equal to 8. Because this is 12, and therefore it's going to be equal to 80. Okay, so then next step, let's split number and letter. So it's going to be 3 power 9 from the log exponential, and then it's going to be 3 power negative q. Number, letter. And then we minus, this is going to be 3 power 7 times 3 power negative q equal to 8. You know what I'm saying? So you see 3 power negative q is common. I can factor that out. I mean, this is common and this is common. Let's take it out. So it's going to be 3 power negative q. So here it's going to be 3 power 9 minus 3 power 7 and then equal to 8. So I can plug in the calculator. 3 power 9 minus 3 power 7. Okay, this is going to give us, let me check calculator. Where's my calculator now? Excuse me. Okay, so 3 power 9, 3 exponential 9 minus 3 power 7. Oh, excuse me, sorry, I made a silly mistake here. Okay, minus 3 power 7. Okay, this is going to give us 174. So here it's going to become 3 power negative q, 174, 96 equal to 8. So since you want to get this, I'll divide by that. You know what I'm saying? I can divide throughout. So you divide by 17496, 17496. So 8 divided by that answer. So 18 divided by answer, and this is going to give us 12187. So this is going to give us 12187, and then equal to 3 power negative q. But what's 3 power negative q mathematical? You know what I'm saying? It's like 1 over 3 power positive q. So if you reciprocate this, it's going to be like 1 over 3 power positive q equal to 1 to 187. So mathematically, you know, you can flip there if you want. Either you can cross or you can flip. So you can only flip if there's no, okay, let's just cross or let's flip it. If there's no something plus here, then you can, only when you have a one group, you can flip is acceptable. But not when you have, let's say, plus something, don't flip, okay? Or if you don't want, you can cross multiplication if you want, or you can flip. But me, I'll just flip 2 7 times. So this one you flip is going to become 3 power q. And this is over 1 means 3 power q over 1, and then this going to be what? 187 over 1, which is going to be same thing. So then after that, because this over 1 is 3 power q, this over 1 equal to that. Okay, so what we're going to do now, we have to think of 3 power 1 equal to 187. 187, I think is 3 power 7. Let's try. Yeah, 3 power 7. So this is going to become 3 power 7, and this is going to become 3 power q. So our q equal to 7. Okay, q equals 7. So if I get my q equals 7, I can get p. Because I can take this 7 here, q, and then I can say, well, what is a pp? I can substitute either here, or I can substitute either there, you know? So now, let's get our p. Okay? So if that's a q, to get p is easy. Because I'm going to take this q, and then I either can substitute in the first equation, because this is a p, or this equation. So whichever one you want. Okay, let me substitute either this or this. Or let's substitute it. So our p equal to 4 minus, okay, 3, 7. And what is our q? Q equal to 7 also. So minus 7. 7 minus 7 equal to 0. So it's like 4 minus 3 power 0. You know what I'm saying? So any number positive equal to 1. Any number power 0 equal to 1. So 4 minus, because this equal to 1 and equal to 3. Oh, so our p equal to 3. Oh, okay. So now we know p and we know q. Our p equal to 3, q equal to 7. Oh, so now our p equal to 3 and q equal to 7. So for that case, I know the value of p, I know the value of q. So I can rewrite my logarithm function. So I don't need this now, I'm done because I need a space. So I'm going to erase this, you know what I'm saying? So let's erase. So quick, erase this, man. We need some space here, man. We're trying to be stingy so hard. So we can have some space in here, okay? Okay, cool. So we got it. Okay, so now I can rewrite because they say, what do they say? Use big, hence write the equation that define h. So this is the equation define h. Let's write it. What you waiting for? Oh, so h of x. This h of x now is going to become log. Let me write it up there so I can have more space. H of x now is going to become log under bed 3. What is our x? X is just x minus p. What is our p? P equal to 3 instead of 3. P over 3 and then plus q. What is a q? Q equal to? Q equal to? Q equal to 7. Yeah, q equal to 7. Yeah. So now we have the equation of p. Alright, man. Whoa, what do they want next? So for the next one, they say B. Right said represent domain and range of h. Domain and range of h. Okay, so what is a h? These are h here. Domain and range. Okay, so domain. Okay, excuse me, just I want to drink your water just a little. Okay, cool. So now we want to go right domain. Domain, let me tell you something. I think we did this yesterday. So, excuse me, I was maybe saying we did it from previous question. Okay. So if somebody give you a logarithmic function, let's say somebody give you log of let's say x minus 1, it could be any base. They say this, let's say is g of x. Find domain of this. So back in your mind, you know, okay, so for the logarithmic function to be defined, anything in front of the log, it must be greater than 0. You know why? Because you say log of 0. Don't worry about that. Log of 0. If you plug in a calculator, check your calculator, plug it in, it's going to say error. If you put, let's say 0.1, it's gonna give you the answer. Plug in a calculator. Why? So any number in front of the log, it has to be greater than 0, not even 0. If you put negative number here, it's gonna say error. It's gonna be greater than 0. Try, check your calculator, try. You know what I'm saying? So for that case now, if somebody say find the domain of this, so don't look like, oh, x minus 1, which number? Just say whatever is in front of the log, it must be greater than 0. But what is in front of the log is x minus 1. So I'm going to say domain of g, x are element of all real number, means x must be a number. But for this case, this, whatever is in here, take exactly, it must be greater than 0. You know what I'm saying? And then after that, you can just solve normal. You say this is, you take over. Oh, okay, so, and then you write x are element of real number, domain of g. You know what I'm saying? So this is your domain. X must be greater than 1. You can even try here. So don't think of a number, just do this methodology. S greater than 1, what does that mean? For example, if you take 1.1, it's going to work. For example, say 1.1. What is 1.1 minus 1 equal to? 0.1. A log of 0.1, it gives us. You know what I'm saying? Try a number, let's say less than 1, let's say negative 2. When you plug negative 2, it's going to be error. So sometimes they give log, let's say 2 minus 4. Okay, let's say it can be any number here, let's say 7. And this is f of x. Let's say, okay, tell us domain. So what you want to do, don't look like, which number now? I'm thinking, I don't know. No, just say everything in front of the log, it must be greater than 0 for this type of logarithm function to be defined. Different function have got different methodology. So I'm going to say x minus 2 minus 4. All this stuff must be greater than 0. And then what happened? This is going to go over. So x over 2 greater than positive 4. And then let's put here negative. Let's put here negative. Let's say, for example, let's say this is negative for some reason. You see, so this is negative, and then after that multiply by 2, multiply by 2. So this is going to be negative x greater than, negative is going to come here, right? 2 is going to come here. It's going to be what? 8, because multiply by 2, multiply by 2, 8. So whenever you divide by negative in inequality, the direction the inequality must change. So divide by negative 1, divide by negative this, and this is cancel. So x is going to change that direction because you divide by the negative of inequality. So this value for this function to be defined, this f of x, value of x must be less than negative 8. And here you just write, okay, domain of f equal to x are element of real number whereby x must be less than negative 8. This is going to work. If only it's less than negative 8, let's try just one. If you plug negative 8 here, it's going to be negative times negative 8 equal to positive 80 over 2 minus 4. And this is going to give you 4 minus, oh no, I'm wrong. X must be less than negative 8. What is less than negative 8? Let's say negative 12, negative 9, negative 12. Okay? So if you say let's say negative 12 times negative positive 12. And then over 2 is going to be positive 6 minus 4. 6 minus 4 equal to 2. Oh yes, so log of 2 is going to give you the calculator. So I'm going to do the same game here. Let's say, so let's go back to our question. You know what I'm saying? You know, I want to make sure that you understand all the concepts so you can do this stuff by your own. So I'm going to do the same approach here, right? For this to get domain of h of x, we know anything in front of this log here, it must be greater than 0. You know what I'm saying? So we're going to say, oh, so domain of h, we know x are element of real number, whereby anything is there, which is there, x minus 3, we know must be greater than 0. And then we just take over. So x greater than 3, and they say x are element of real number, or domain of h, whereby, so this is a domain. You can try take a number which is greater than 3, like 4, 5, 6, plug in the calculator, you see, say log, because say greater than 3. So it's going to be, let's say 4. So it's going to be log, base 3 is going to be 4. 4 minus 3 equal to 1 plus 1. You see, this is going to work, because log of 1 equal to 0 plus 1 equal to 1. Check a number, you can try it. You know what I'm saying? So now for this case, this is going to be our solution, okay? The solution is only here. We're done. Now, let's say find the domain, right? Oh, yeah. See, so for this function to be defined, it seems like this graph it did cut at 3 here. Even if it's not mentioned, it seems like, see, look, it did cut here, it seems to be 3. So the domain is like from here all the way, but anything can be defined must be greater than 3. You know what I'm saying? Now let's go. What do we want now? Use the graph domain there. Write down the set to represent domain, range. Okay, range. So for range, okay, so now we go for what? For range. So for logarithmic function, range, okay. Range, let's go. A range of, okay. So for range, say, range means the value of y, where, okay. Some people sometimes don't know how this domain and range works. Let me just explain quickly for range. If somebody gives, let's say, graph of this, what is range of this graph? Let's say the g of x. So range is the value of y. But that value of y, it must be on, okay, let me say in simple word. It must associate with the graph. For example here, and always start from the negative. Okay, this graph go to the negative, so now what you do, okay, start from the negative. Okay, this is what you do. If they ask for the range, work on y-axis. Work on y-axis. Now, let's work now. Start from the negative. When you work, you must look at the graph. Look, I'm working on y. But you must look left and right. Okay. Okay, now I'm walking. I look here. Do I see the graph? Yes, I see. You see, because this graph go all the way. I see. Oh, so this graph starts from negative infinity. Because even here, I'm going to see the graph. Because I must look left or right. Look, I see. I see. Because this graph, remember, goes, I see. So that's why it's going to start from negative infinity. You want to see where I'm going to stop seeing it. I'm going to see. But I'm walking on the y-axis. But from here, I'm going to start now to see. So this graph is going to go from negative infinity to 0. The value of y of equal to 0. But remember, it does not touch 0. Because it comes, but it does not touch 0. Because when you hear exactly at 0, you don't see this graph. You only see x-axis. So it's going to go to 0, but it's excluding. Even negative infinity is excluding. Because you don't know exactly where negative infinity. You know what I'm saying? One more example for the for range. Okay, so somebody give you this, for example. Okay. Find the range. So I'm going to get domain and range, for example. Okay. Now let's have domain. Domain of x. Let's say this is k of x. So I'm saying domain of k equal. So for domain, you work on x. You know what I'm saying? And then you look at the graph. But whenever you work, you must start from the negative. Okay. Now let's go. So I'm going to start from here, this side here, from the x, because the domain is value of x. But this value of x has to do with the graph. So if I walk from here, look, I'm going to be walking. You walk on it, then you must look up and down. You walk while you look up and down. Do you see the graph? Yes, I see, because this graph go. Oh, I see. Oh, so this graph starts from, okay, x are element of real number, but whereby this starts from negative infinity. Now, I see that because if when I'm here, I'm going to see the graph, because this graph continues. I walk here, remember, then I look up and down. I see, but this is the last point where I'm going to, here I'm not going to see the graph, because if I walk on the x and look up and down, I don't see anything here. But here, I'll be seeing the graph. So it's going to go from negative infinity to 0, but this 0 is including, because even when I'm here, I'm on it. I see it, which is not the same with the first graph. So start from negative infinity all the way to 0. Oh, so domain, I am a real number, but x start from negative infinity, excluding, let me write bigger a little bit. I would say x are element of real number, domain of let's say k of x, whereby this is start from negative infinity, excluding value of x, and they say, but are including 0. Because if you don't write like this, you can say x are element excluding negative infinity to 0, but 0 is including for this case. You know what I'm saying? Now let's do range quick. Range also, I'm going to do the same thing, but I've been working on the y, because range value of y. So I've been working from here now down. Okay, so range of k equal x are element of, no, it's not x, it's y, my apology. Y are element of real number. Okay, now, if I'm here, do I see the graph? No. Because you walk on it, y, for range, they look left and right. No, I don't see the graph. Don't look like that. You walk and they look this way. You know when you walk like this? But you walk while you look. Do I see? I don't see. Do I see? I don't see. Do I see? Okay, so now let's walk now. Do I see? While I'm walking, I don't see. But from here, I see. So when I go to 0, but this 0 is including. Okay, so you can write this format and then write y, and then, no, I see. While I'm walking on the y, I see. Even when I'm over, I'll see, because this graph continues to positive infinity. But when you write infinity, you don't include, you always exclude. If you don't want to write like this, say y are element, we know 0 is including for this case, but to positive infinity, excluding. So that's how you get domain and range for. But for this case now, if we look at the graph, now the one range. So range means I must walk on the y. Look, means this graph continue. I mean, if I'm here, I'm walking on the y, look left and right. I'll be seeing this graph because this graph continue here. You know what I'm saying? This graph continue with no. So if I'm here, I'm walking on the y, I'll be seeing this graph because even though it's top here, but it continue. I see. Oh, so for this case now, so this is not part of the question. This was just showing you. Okay. So range of what? The range of h. Okay, so we're going to say range of h equal y are element of real number, but where does it start? if I'm here, I'm going to be seeing this graph. So from negative infinity, but a negative infinity excluding. Always start from the negative. Either x or y, you must start with the negative. So I go, do I see the graph? Yes. I see the graph? Yes. I see the graph? Yes. I see this graph. Even if I go over, you see this graph continue. Like, look, it kind of continue like this. So I'm going to see either way. So from negative infinity, y to positive infinity. But or if you don't want to like this, you don't want to write like they can say range element of excluding negative infinity, because infinity does not include it, because you don't know where you're going to start or where you're going to stop. And they say to positive infinity. So this is a range of h. You know what I'm saying? So we got range and domain already. And let's say find the equation of the asymptotes. So asymptotes. So equation of asymptote for logarithmic function. You see this one here? You take this equate equal to 0. You take that one and then you equate equal to 0 for the equation of the asymptote for logarithmic function. So sorry, I'm just drinking the water, just made, right? Okay, cool. So for asymptote, if somebody give you, I like to give examples so you get to understand. So for here, I'm going to say, so say for asymptote of logarithmic function, for this for logarithmic, take whatever is in here, equate equal to 0. So you say x minus 3 for this case equal to 0. This is for asymptote of logarithmic function. You know what I'm saying? But for the other function, it's going to be another story. But for logarithmic function, equate equal to 0. So say x equal to 3. So this is the vertical asymptote. Just say asymptote, that's all. You know what I'm saying? So your asymptote equal to 3. X equal to 3. Another way. You know what I'm saying? So it's 3. So even here, this is not exactly it cut at 3. It's like it's very close to 3, but it did not cut. Because asymptote means the graph will never touch that coordinate. So means this one I was wrong, because this graph is like maybe here 3 did not cut. It came very close, but it never, like if I have to put like straight line, for example, means this should be 3, because asymptote is where the line, the graph will never cut or never touch. Means this graph here is like, there's a 3 here, 3, where this graph is going to come closer, but it never touches. It's going to be like next to it, but it never touch. You know what I'm saying? Never touch this one. X equal to 3. You know what I'm saying? So this is how you get the asymptote, and this is the vertical asymptote for this case. So vertical asymptote, you can see is vertical. So this is vertical asymptote. You can say vertical asymptote exactly, but I just write the abbreviation here. You know what I'm saying? Excuse me. So I say vertical asymptote. Asymptote equal to that one. Okay, so this is the answer. So sometimes they might give stuff like this. You know what I'm saying? Just a minute. So that's your answer, right? For asymptote. So they might give stuff like this, for example. That's our answer already. We got it. So we have all the domain and range of just erased because we don't need them. So if somebody give me, for example, let's say a log, let's say this is 4, and they say x over 2 minus, let's say 3 plus 7. So what is the asymptote, vertical asymptote of logarithm function? I'm going to take this equate equal to 0. You know what I'm saying? Let's say this is k of x or whatever x function. So say x over 2 minus 3 must be equal to 0 for asymptote. Take over, it's going to be x over 2 equal to 3 positive, multiply by 2, multiply by 2. Multiply by 2, this is going to be x, this is to cancel, equal to 6. So this, our vertical asymptote, is when x equal to 6. You know what I'm saying? If it is like that. So it all depends how they're going to give to you, okay? So that's not part of the equation, but just important for me to explain to you. Describe the steps of the transformation. Okay. Describe the steps. So this is not part of the question, like I said. Well, I'll just explain to you. Okay, here things we got log, it was log, and a base 3 if I'm not mistaken. Yeah, oh yeah, yes. Okay, now, describe the steps, okay, that we gonna subscribe, describe the step of transformation process would you apply to the graph of h to obtain y equal to this. Oh, what is a h? So this is h. You wanna see how could you transfer this to get to obtain what? Y equal to log 3, log x 3. Oh, okay. So first and foremost, look, if you look careful, when I move here means this, it went away. So if it went away, what that means they eliminate it. Means you take it out. If you take it out means you minus. How you gonna, okay, if I have something like this, let's say this 6. And now we don't have this. So how did it get, excuse me, let me give you an actual example. This 7, and then now it's 0. What happened means I went down to get from 7 to 0. Remember this is y, this represents y. Okay, you know what I'm saying? So it moved 7 units down, or in other way, they subtract that y. So it's like for y to move to here means you move 7 units down vertical, okay? Vertical. So that means the transformation phase, they move 7 units down. Oh my God, come on man, where you falling? Keep it falling, keep it falling. What's the problem with you, man? Hey, come on. Okay, so now the phase on the transformation, we're gonna say shifting graph 7. Okay, so we're gonna shift a graph what 7 unit vertical down, downwards. Okay, so we shift 7 units what down. Okay, now, and then what happened with this? Look, it was -3. Now, okay, look. Oh, I love this. I think I explained another video, but let me explain again. So for y, that's how you do. But for x, is a little bit different. So for x, this is what you say. Understand also when we write, so you don't have to spend a lot of time, start of stress, like, oh, what? Oh no, how do you know that for x? If I have an x, oh no, let me just go straight. So for x, look, this was -3, and it became x. So what that mean? It means for them to become x, they +3. Look, if I have a -4, if I +4, oh, excuse me, let's say I have a x -3. How is gonna get to? How is gonna get to just x? It's gonna get to x because they add by 3. You know what I'm saying? They add by 3 to get x. So now, for x-axis is kind of different. Okay, listen to me carefully. For x-axis, when you plus, means you move to the left. It's kind of crazy, but just know that. Because you expect when you plus something, means you move to the right. But for x-axis, no. Just simple as that. For x-axis, when you plus something, you move to the left, and when you minus something, you move to the right. Please understand and memorize, just to save your stress, okay? Now we go. So for that case here, now let's go. It was -3, how did it move to? X minus -3 means they added by 3 to get x. So we say for x-axis, if we plus, means we move to the left. But how did you plus? How many units did you plus? We plus by 3. So we shifted the graph 3 units to the left. So by shifting, then shift the graph 3 units to the 3 units, because we plus 3 units to the left. You know what I'm saying? Oh yeah, that's how you got it. And that's the answer. So how if, for example, it was, how if, for example, they say, this is the answer, right? We're done with that part of shifting. How if, for example, so let me challenge you a little bit. How if those K, they could have said stuff like, okay, so that's gonna be homework. I want to challenge you a little bit, you know what I'm saying? How if it was +1, and then this is, let's say, +3. Now, tell me, let's work together. How can you move here? Explain about shifting. This something has nothing to do with equation, you know what I'm saying? Now we go. From here, how are you going to get to +1 here? I think you must +4. You know what I'm saying? Because if I take this, +4 is going to give me -1. So I'm going to say, oh, since a +4 and it's on x-axis, for x-axis, when you plus, means we move to the left. You know what I'm saying? So you're going to say, oh, so the graph was shifted what? 4 units to the left, or horizontal. Horizontal, so this could be horizontal, so horizontal. Okay, cool. Now let's come here. But for y, no, for y is not like x's, right? Y is just what you see. From 7 to 3. What does that mean? It means they remove what? 4. So look, if this 7, if you want to come to 3, it means you go down. So the graph was shifted 4 units downward. You know what I'm saying? So that's how it is. That's how you done. How if, let's say it was -1 here? How you move from -3 to -1? Oh, means you plus what? 2. So from here to here means the plus what? 2. But when you plus, what does that mean? Means you move to the step to the left. Okay, how if it was -5? Okay, let's say -5. How do you get from -2 to -5? To -2 to -5 means you must minus. So when you minus for x-axis means what? You move 2 steps to the right. That's very important. You know what I'm saying? So for here to here, because they say how you get -3 to -5 means I must minus or 2. So when you minus means the graph was shifted 2 units. Since you minus, means it's going to be to the right. 2 units to the right. Listen, man. This is not about this, so I don't want to start here, okay? Let's go to the next question. Use the graph to determine the M and C. Oh, M and C. So, okay, so M and C. Okay, cool. Cool. Use the graph to determine M and C. So we know O. So y straight line equal to mx, mx plus c. So the one that's to find slope and y-intercept. So this is easy. So I have to look at the coordinate which lies on that straight line. Which are coordinates? We have these lies on this straight line, and even this also lies on that straight line. You know what I'm saying? So 4 and 7. And also coordinate, which coordinate? 12 and 9 lies on y equal to mx plus c. So let me start with the 4 and 7. So y equal to 7. Okay, m, I don't know. What is the x equal to 4. So it's going to be 4m. 4m and then plus c because 4 times m. Okay, so I can call this first equation. So we do the same thing for the second one. For the second one, 12 and 9. So y equal to 9. And then x equal to 12. So this is going to become 12m. Go 12 times m, 12m plus c. Let's call the second equation. So for that case, I can solve this simultaneous. You know what I'm saying? Okay, let's make one subjects. I can say if I make c subjects here, or whichever one, man. If I make these c subjects, what happens? It's going to be c equal to 7 minus 4m. So my c equal to 7 minus 4m. So this, let's call third equation. So this is going to come in this another equation. And solve simultaneous, you know what I'm saying? But if you have other way of solving simultaneous, you can do it. So now we have a 9 equal to 12m plus c. Instead of c, I put 7 minus 4m. 7 minus 4m. Always put your bracket because if this is negative, you might change everything here. So you got 9 equal to 12m. 12m minus 4m equal to 8m. 12m minus 4m equal to 8m. So this is going to be 8m and then plus 7. 7 go over. 9 minus 7 equal to 2. 8m divided by 80 and then divided by 80, so this and this cancel. So m equal to 1/4. So we got m. So if we got m, then we can get c because I'll come and substitute in this equation because we need c now. Then our c equal to 7 minus 4 times m. m equal to 1/4. So this and this cancel, so it's going to be 7 minus 1 equal to 6. Our c equal to 6. So for that case now, y equal to m. We know m 1/4. And then we have a x plus c equal to 6. So this is straight line. And slope is possible, make sense, look. And y-intercept is somewhere here, can you see? And it makes sense, y-intercept possibly could be 6, make a lot of sense. You know what I'm saying? So we got straight line, now we're going for the last question. You know what I'm saying? Let's go to the last question now. the value, use the graph of H and L, not algebraic, by graph intersect. Why do I say intersect? Because these graphs are equal. Take over and then they're equal. And whenever two functions, two graphs are equal, means where they intersect. So we want to get the value of x, where let me say where f of x and g of x and l of x and h of x, l of x and h of x, l of x and h of x intersect. How did I know that? Because they are equal. So for that case, where do they intersect? When x equal to 4, all the way to, you see this point is where it intersects, 12. So these are value of x. So x are element of including. Why they include? Because it actually can see 4 and 12. If you don't write like this, you can just say x including, start from 4 all the way to 12. And here you can say x are element of real number. That's how we do. Easy, man. That's how we do. You face time, man. You know what I'm saying? You can shout to a lot of people. This is bacteria. Oh, now I breathe a soldier, like I told you. So that's how we solve, you know. And if you have any question, please leave a comment. I'll be more than happy to respond to your comments and give you that beautiful love, like love. You know what I'm saying? So, man, easy, man. I'm gone.